So the first question is, what is C2E2? C2E2 is a verification tool for nonlinear hybrid system. Imagine this block is the C2E2 software. It's currently on the Ubuntu. It's able to compute the reach tube to verify certain requirements. It has a complete user interface to edit model, plot the results, and more. So for the input, you will need some information about your model, such as model dynamics, which describes your model by a set of differential equations. Second is if your model is hybrid, which means it has different modes, then you can provide how your model transits between each mode. Also, there are more stuff like initial set and unsafe set, which I'll talk about them later in the talk using a real example. So the output will be reach tubes, or simply how far it can reach in each time intervals, which can then determine safety requirements. For example, if the reach tube is not intersecting with the unsafe region, then it's said to be safe. Moreover, you can visualize these reach tubes by using the C2E2 built-in plotter. So before demonstrating the C2E2 example, I want to mention why do we do this reachability analysis. So in an ideal world, we have perfect information about everything. We can just simulate the model and then we can confidently know its state. However, in the real world, sensor will have accuracy problems. Maybe models are not 100% correct. Also, there will be uncertainties from environments such as frictions. So we can't cover all this infinite number of cases using only simulation. That's why we do reachability analysis to guarantee the safety. Let's talk about a simple example of using this software, C2E2. Suppose you have a nonlinear vehicle model to verify. It's shown on the right. It's basically a bicycle model. The vehicle has two wheels, the front and the rear wheel. And here, L represents the length of the vehicle. So here are the dynamics of the vehicle, which is just a set of differential equations. Let's define the X and the Y to be the position of the rear wheel. So X dot and Y dot will describe how the position of the vehicle change. And here, theta dot will describe how its heading angle change. Besides these dynamics, you will also have to provide initial condition for the vehicle. So why do we use an interval instead of a precise point? It's the same reason, because that in real life, there might be uncertainty like sensor accuracy, so that you can't really give a precise point of the vehicle. These are two basic information we need in order to run the model in C2E2. Of course, there are other parameters we have to set, which I will talk them in the next couple slides. All right, let's visualize this vehicle model with a scenario. I put 2 waypoints on the map for the vehicle to reach. The first waypoint is the little green dot on the upper part. The second waypoint is the little black dot on the bottom, which is the goal waypoint. The orange box around the first waypoint represents the guard, which simply means when reach tube of the vehicle touched the orange box, you can think of it as a trigger, so that the vehicle will start to follow the second waypoint. So let's put this vehicle at the initial condition. I will draw the trajectory that vehicle follows. It will be a bit ugly, but it will roughly shows how vehicle proceed in this scenario. So here, the green trajectory is in mode 1, which the vehicle will follow to the first waypoint. And then the black trajectory means vehicle is in mode 2, which it will follow to the second waypoint. Also, there's an unsafe set, which represents obstacles in this scenario. For example, you can put an obstacle here to check if it has intersection with the reach tube of the car. And all I want to show here is a rough picture of how this verification scenario will look like, so that you might have a more clear picture of the model I will use in the C2E2 demo later. Before going into a real C2E2 software, I want to introduce how C2E2 represents this scenario in the previous slides. So C2E2 actually uses a file format called the HighXml file to describe all this information in the model. It looks like this, but don't freak out. It might be hard to manually write these HighXml files. C2E2 has a model editor to let you create its model more easily. And next, I will do a short demo using C2E2 software to verify the system we just discussed. So I'll switch to the other machine. Once we start up this program, this is the main interface that of the C2E2. So as you can see, if you want to load a model from the HighXml file, you can click the file here and then open, and then navigate to the HighXml file we want to verify. So here I will use the model that we just discussed in the slides. So once we open up this model, you can see there's a white region here on the left, which is the workspace you can edit your model in a tree. So as you can see here, this is the name of the automata. And then when you click on it, it will show variables, modes, and then transitions. For variable, it's just the state variable of your model, which here is the X, Y, and the theta. For modes, we have two modes here. The first mode will let the model to follow the first waypoint, which it's just simply a set of the differential equations. So, yeah. So as you can see here, this is a set of differential equation that describes the model for the first mode. Here, the data dot will be a little bit different because it will navigate this car to the waypoint 66. Also, the second mode is basically the same except for the point change to the 5 and -5. So the next will be transitions. There will be only one transitions, which the car will switch from following to the first waypoint to following to the next, following to the second waypoint. And in the transition, you can set a guard here, which is the area that when the car reaches the guard will switch the mode to following the second waypoint. So this is all about the model tab. And on the right, you can see there's a requirement. This is the name of the requirement and the time step and the time horizon, which time horizon is just simply the time bound, like how long do you want to verify or simulate this model. And for k-value, we don't need to worry too much about k-value here for now. For simulator, we are using the default. And for refinement, we are also using the default refinement strategy. And since this is a non-linear model, so we don't need to actually care about this option here. But this is a new feature I implement in the C2E2. So this urgent transition checkbox is also a new feature that I implement, but we can leave it as empty now. So for initial set, there's two parts in the initial set. So the first part will be the initial mode that you want the model to be. So we set this to follow 1, so it will follow to the first waypoint. And then the second part is a set of inequalities that you of your initial condition. And then for unsafe set, it's just a set of inequality that your obstacles are. So once you have all this information, you can click verify to verify the model. So let's just wait a couple seconds. So once you finish the verify, it will show the results on the bottom, which shows results is safe. So it means that the ridge tube is not intersecting with any unsafe region. So besides that, we can plot out the ridge tube using this plot tab. So we can click to the plot tab. So for horizontal axis, we want X. So for vertical, we want Y, so that we can visualize this scenario in a 2D plane. So we can plot this scenario, and I might need to like show this plot in the browser. So I meant to stop rich tube that you just verify. In the vehicle, it starts from 1, 1, and then it follows the waypoint, first waypoint, which is 6, 6, and then it will switch the mode here, and then goes to the next waypoint. It stops here because I set the time down to smaller than it needs to be. So it will just stop here. And that's basically the plot that of the rich tube that you just verified. Find the rich tube data in this project folder, which you can click into the work directory, and then click to the output, and click to the requirement that you just specified, which is the follow waypoint. And then you can also find this data in this text file. So that's basically how you will open the model and then verify it. So besides verification, you can also do simulation using the C2E2. It's just the same model you will use, the same requirement you will fill in. And then except for clicking the verify, you will click simulate. And it will give you back the simulation trace of the model. So let's see. Also, I'll plot the same axis. So as you can see, the simulation trace will look like this. It will not blow this simulation trace because it's just only a simulation. And that's basically how you will do simulation in C2E2.